Here's a question that almost always comes up in a data science interview. Can you explain the difference between classification and regression? Now, this might sound basic, but interviewers use it to test how clearly you understand the foundation of supervised learning. Here's how you can answer it like an expert. Both classification and regression are supervised learning problems, meaning the model learns from labeled data. The difference lies in what you're predicting. In classification, you predict a discrete class or category. The output is categorical, like spam or not spam, dog or cat, positive or negative. You're basically teaching the model to choose the correct label from a set of options. In regression, you predict a continuous numerical value, something that can take on an infinite range, like house prices, temperature, or sales. So instead of picking a label, your model estimates a number. A clean way to phrase it in an interview is this: classification divides, regression predicts. Then add a quick example. For instance, predicting if a patient has diabetes is classification, while predicting their blood sugar level is regression. Short, sharp, and clear, that's exactly what interviewers love to hear. Now, if the interviewer pushes further, and they often do, they might say, how does your approach change between classification and regression? Here's where you show practical understanding. And this aligns perfectly with how you'd describe it in a real project. Let's start with evaluation metrics. For classification, you'd use accuracy, precision, recall, F1 score, or AUC ROC. Metrics that measure how well the model distinguishes classes. For regression, you'd switch to numerical error measures like MAE, MSE, RMSE, or R-squared. Next, algorithms. Classification often uses logistic regression, decision trees, support vector machines, or a naive Bayes. Regression, on the other hand, uses linear or polynomial regression, ridge or lasso regularization. But note this: some algorithms, like decision trees and neural networks, can handle both, depending on how you frame the target variable. Then comes output interpretation. In classification, the model outputs probabilities or class labels, often with a threshold, for example, classifying as fraud if the probability exceeds 0.8. In regression, the model outputs a specific numeric value, say, predicting a house price of £260,000. And here's a great interview insight: sometimes these two overlap. You might convert a regression problem into classification, for instance, predicting whether a house price is above or below £500,000. Instead of predicting the exact value,